So this is our part for Model Mania 2018. You can see it's kind of looks like a yoke of some sort. It's got a cylindrical boss at the top and a couple of legs or fingers hanging down on the side, and then a 10 millimeter hole that runs through it. So let's go ahead and take a look at how we would approach modeling this. So I'll start on the front plane, and I'll get the basic shape of my design out. I'm going to start by drawing a construction line. This is going to be 40 millimeters vertical. And then we'll add a couple of circles, 48, which is 24 times 2, and then 22, which is 11 times 2, as indicated on the drawing. Then we're going to draw down those legs or fingers that hang down the side, close them up, and then capture the tangency as we sketch that. I'm going to add a dimension to define that draft on the outside finger. That's going to be 7 degrees. And then we'll mirror this to the other side. So once we have that all mirrored, I'm going to hold down the Alt key and Control and then select those contours and go ahead and extrude this about the midplane, and we'll just pull this out. Now I don't know what the depth is, so I'm just going to make this 40 millimeters at this point because we're going to cut some material away. So I'll pick up the silhouette edge at the top, transition down, and then just by moving my mouse back to the original point, I can transition into a tangent arc. Then we'll add a vertical center line, and I'm just going to drag this down onto the origin, and that actually establishes my symmetry for my design. So we'll make this 2 degrees of draft as indicated on the drawing, and then we'll add a 10 millimeter circle in there. Add another dimension here at the bottom. This is going to be 10 millimeters, and our sketch is fully defined. Now we're going to cut some material away. We're going to go through both sides and then flip the side to cut. That's going to cut material away on the outside. And there we have the overall shape. So on the top plane, I'm going to sketch a circle. This is going to be 26, actually 2 circles, and 18. This is going to define that cylindrical boss that we have in there. And we'll go ahead and extrude this. I'm going to choose the From option and choose an offset of 67 millimeters, reverse the direction, and then let's try up to surface and choose that inside surface. So that's not going to work because our boss is larger than that inside surface. So I'm going to choose up to vertex. And that'll establish some parametrics in my model instead of just putting a blind dimension on there. I'm going to reuse that sketch to cut that material away at the top. And this is going to go through all, select the contour, and we'll choose that inside contour, reverse the direction. It'll go through everything. That cuts that material away. Now we're going to need to remove the extra material created by the boss. So I'm going to create a sketch on the front plane and convert those two selected entity edges into sketch geometry, extrude this through both directions, and it just cuts that material away for us. Finally, we need to add fillets, so I'm just going to go ahead and add fillets onto my model. These are going to be 2 millimeters. All I need to do is choose those 2 faces, and Solidworks wraps all those fillets all the way around. Now this isn't necessary. I like to do it just for visual purposes. Change the color of the fillet. It helps me visualize and see that fillet has been applied all around. And the last thing we do is we apply the material, which is plain carbon steel. So that's the first part of Model Mania 2018, or what we call Phase 1. What we do next is you're then given a drawing to make changes to the same model. So this is the Phase 2 drawing here. You can see if we look at the 2 views on the left, you see some offsets of 5 millimeters. That indicates to me that maybe we try shell there. And also in that center view, the lower center view, you can see that the 11 millimeter radius needs to move down to 32. We also ask you to run a simulation, so you can use SolidWorks Simulation or Simulation Express. We've defined where in the upper right hand corner there, you can see that we've defined where you hold the model and where you apply the load and how much load to apply. So let's go ahead and take a look at how we'd approach doing Phase 2. The first thing we might want to try is to edit our first sketch. And if we go in there, you can see that those 2 circles were drawn using the same center point. So those points are merged and can't be broken. So we're going to need to figure out another way. An easy way to do this is to use the Move Face feature. So I'm going to roll back in the tree, choose that face, and just hit the Move Face button, drag that down 8 millimeters. That gives us 32 for the center distance to the bottom for that particular hole. I mentioned shell earlier. It might be a great opportunity to use shell to get our 5 millimeter offsets. So we'll key in 5 millimeters for that. And that takes care of creating all those offsets for us. Now all we need to do is roll down and see how the rest of our model behaves. Everything looks pretty good. And finally, deal with our fillets. So in this case here, there's a lot of additional edges that have been identified through that shell. So I'm just going to choose to fillet the shell feature. That's a very powerful tool in SolidWorks, and it's been there for quite a while, but it's really pretty powerful, and it gives you a quick and easy way to get all the edges associated with that shell feature. It's pretty nice. Next, we ask you to run a simulation. So we'll just create a new simulation. It's just going to be a static study. And then we define our fixtures. So the fixtures as defined on the drawing are going to be those two lower cylindrical holes. We'll go ahead and accept those. And then we need to define our load, which is going to be a vertical force on the cylindrical face at the top. And it's going to define the direction to be vertical, defined by that top face. And it's going to be 10,000 newtons. So loads defined, material defined, boundary conditions defined. Last thing we need to do is to run our simulation. SolidWorks solves that. It's not necessary, but I always like to just run an animation of a stress plot or a deflection plot, and that helps me understand, is the model behaving as expected? In this case, yeah. And then all we ask for is what is the factor of safety. In this case, about 2.8. So there you have it, Model Mania 2018.